You have the mass of the empty flask, the mass of the flask with the acetyl salicylic acid that you used. With those two numbers, you can calculate the mass of acetyl salicylic acid that you have. It's just the difference between them. Now, to convert the mass of acetyl salicylic acid to the moles of acetyl salicylic acid, you can divide the mass by the molar mass, which is 180.16 grams per mole. That's from your lab manual. And that will give you the moles of acetyl salicylic acid. Now in number 5, you have to calculate the molarity of your stock solution. That's the solution that you prepare after heating your acetyl salicylic acid with the sodium hydroxide. You transfer that into your 25 milliliters volumetric flask. You diluted your solution all the way to the line with distilled water. That's your stock solution. Since you know how much acetyl salicylic acid you use, you can calculate the molarity. You have the number of moles, you have the total volume, and you can just divide the number of moles, which is what you have in number 4, by the volume in liters, which is going to be 0.025 milliliters, liters. So that's giving you the concentration of your stock solution, which I'm going to label as C1. Okay? Now you're preparing 5 standard solutions, and the volumes that you measure were in microliters: 100, 200, 3, 4, 500 microliters. Since we're going to be using the dilution equation with 2 volumes in there to have the same unit of volume, I converted the volumes from microliters to milliliters. That's why in my table I have 0.1, 0.2, 0.3, 0.4, and 0.5. That those volumes are in milliliters. Now the total volume is the total volume of the volumetric flask that you use. Okay? So you were diluting with the iron chloride all the way to the line of 10 milliliters. So that volume, I'm labeling that one as your volume 2, the 10 milliliters, which is the total volume of your volumetric flask. Volume 1 is the volume of the stock solution that you're using, your 0.1, 0.2, 0.3, 0.4, and 0.5. Now to calculate concentration of acetyl salicylic acid in your dilutions, your 5 standards. That right there is concentration. That's acetyl salicylic acid. So brackets represent molar concentration. So you can calculate the molar concentration for all of your standard solutions using the dilution equation. C1 and V2 is the same for all 5. C1 is the number that you have in number 5. V2 is the total volume, which is 10 for all of them. So the only thing that is different in your calculation for your 5 standard solutions is the V1, which is the volume that you're taking from your stock to prepare the dilutions. A, it's for the absorbance that you measure. So your experimental data is the absorbance, and everything else you're calculating. Now you're preparing these 5 standard solutions with known concentrations. So we can prepare a graph and use that graph to find the concentration of acetyl salicylic acid in the solutions that you're preparing using the aspirin tablet. So in your graph, you need in the y-axis the absorbance, and then in your x-axis you need the concentration. So the concentration of your 5 standards, that's C2, and then the absorbances that you were determining for your 5 dilutions, that goes in y-axis. So for you to prepare the graph, you're going to use the squared paper, graph paper from your notebook. You have to choose a scale for your y and your x-axis. It does not need to match. Okay, you need an own like a specific scale for your y-axis and another one for the x-axis, and you're going to determine which scale to use based on the numbers from your experimental data. So I have some numbers here. This is an example. So looking at the numbers, if you check your absorbances, you have 0.148, 0.243, 0.401, 0.523, and the highest one is 0.677. So looking at those numbers, you need a range of absorbances that goes from 0 all the way to maybe 0.7, because the highest one is just 0.677. So you can start at 0 for the y-axis, which is the one for your absorbance. So I'm going to put 0 right there. And then the increment that we're choosing, if you see 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, that increment, it's okay. You can make your graph with that y-axis increasing by 0.1. So I'm defining, like in my y-axis, each square in my graph paper has a size of 0.1. So 0 to 0.1, which means that another square has a size equal to 0.1. So you go from 0.1 to 0.2. Third one, 0.3, 0.4, 0.5, 0.6, 0.7, and so on. Now for the x-axis, which is where you have the concentration. Absorbance there. And let's put concentration here. So for the x-axis, your values are 0.011, 0.22, 0.33, 0.44, and the last one 0.055. So the smallest one is 0.01 and the largest one is 0.05. So you can start at 0 and you can do like 0.05. 0.01 here, 0.2, 0.5, and the last one 0.6. So in this one, I'm defining like two of my squares. They have a size equal to 0.01. I'm defining that size. So every two squares should be increasing by 0.01. Now these are the scales that I'm choosing, and you're using now the graph to put the numbers that you have. So I'm going to do like two of them with my numbers here. So I have my first experimental data. It's the absorbance 0.148, so 0.1, 0.2, and 0.148 is very close to 0.15. That should be somewhere in there. And that one goes with 0.011, so this is my 0.01 right here, a little bit higher than that, just by a little bit. So that's where my first dot it's gonna be. Second one, 0.022, very close to my 0.02. And the absorbance for that one is 0.243, so 0.2, 0.3, 0.25, lower than 0.25. And where those two meet, you should have your second dot. Okay? So you can put all of your dots in similar way, and then you have to trace a line that passes through 0 and contains most of your dots, or pass as close as possible as the dots to the dots that you have in your graph. Okay? I'm just making a line. I don't have all the dots, but you should have something like that. Now the line, it's passing through 0 because the absorbance is telling you it's related to the concentration of the acetyl salicylic acid that you have in solution, right? The acetyl salicylic acid is forming a color or purple complex with the iron chloride, and that complex is the one absorbing the light. Now, if there's no acetyl salicylic acid in your solution, then the absorbance will be 0. So the line is passing through 0 because when the concentration of acetyl salicylic acid is equal to 0, then the absorbance will be equal to 0. So you have your graph, and I have a sketch in another page, so I can show you how we're going to be using that graph. But you have to prepare just one graph with the data that you have for absorbance and concentrations for the 5 standards that you prepared. Now this is the data for your aspirin tablet. So you're determining the calculations in a similar way. You have the mass of the flask with the aspirin tablet, and to that number you're going to subtract the mass of your empty flask. In that way you're getting the mass of the aspirin tablet. The number 4 is the volume of your solution, which is 25 milliliters, again because you prepared this solution in your volumetric flask that has a total volume equal to 25 milliliters. So I'm writing my volume in liters because we're going to use that volume later to find out a concentration, a molar concentration. The dilutions for this part were prepared in a similar way to the ones that you did in the previous part. So you have your volumes 100, 200, and 300 microliters. And in the table, I'm writing those volumes in milliliters. And then your volume 2 is the volume of your volumetric flask, which is 10 milliliters. Now, I'm writing for the absorbances letters. You should have a number. So my letter X, Y, and Z are representing the absorbances for those 3 dilutions that you prepared using the aspirin tablet. So your volume 1 again is the volume of your stock solution that you prepared using the aspirin tablet. And the volume 2 is the total volume of your volumetric flask. Now you have to calculate a concentration of acetyl salicylic acid. Again, in the previous table, you calculated that one using the dilution equation. Because you knew the concentration of your solution with acetyl salicylic acid, you determined the mass, you converted the mass to moles, you calculated a molarity. So you knew that concentration. With that concentration, you were able to calculate the concentration of all of your dilutions. But in this case, we don't know how much acetyl salicylic acid there's in the aspirin tablet. That's what we want to find out. So we cannot calculate those concentrations. To find out those concentrations, we're using the graph that you prepared. That's why you need the graph. So you have your graph with the absorbances that you measured and the concentrations of the standards that you calculated. So I have a sketch here of a graph just to show you what you have to do with the graph to find out those concentrations for your dilutions here for the aspirin tablet. So remember, I told you that I'm using the letters X, Y, and Z to represent numbers for the absorbance of your unknown solutions here. So in your graph, you can see that in my y-axis where I have absorbance, I'm labeling my A, X, Y, and Z. You should have a number, okay? So the number that you have for that letter X, which is the absorbance for your first solution, you're going to find that value of the absorbance in your y-axis, and you're going to move from your y-axis all the way to the straight line that you have for your graph. From the line, you're going to move down, and you're going to approximate the value that corresponds to that absorbance. That value is the concentration. Okay? So if the absorbance is 1 for that solution, you're going to move from that value of the absorbance to the line, from the line down to the x-axis, and you're going to copy how much is the concentration. Same thing with the second one. For the second one, I'm assigning the letter Y. So Y represents the value of the absorbance. I'm going to find out the value of Y in my graph in the absorbance axis. From that value, I'm going to move to the line of the graph, from the line down, and again, approximate your concentration. So that C2 that I have here in blue is the concentration after dilution that corresponds to your absorbance X. That C2 that I have in yellow is the concentration that corresponds to the absorbance that you have for the second standard solution. And then the third one, I'm using letter Z. And again, you're finding the value of your absorbance in the y-axis. You're moving to the line, from the line down to your x-axis, and you're going to approximate your concentration. And that's the third value that you need for the concentration after the dilution. Okay? So you have 3 values for concentrations that you're getting from the graph. And now with those values of concentrations, which I'm labeling as C2, we can calculate C1. Okay? That C1 is concentration of your solution that you prepare with the aspirin tablet. Okay? So remember, you dissolve the aspirin tablet in the sodium hydroxide, you transfer that into your 25 milliliters volumetric flask diluted with distilled water, and from that one you prepare your 3 standard solutions. Okay? So that C1 that you're calculating is the concentration of that solution that you prepare in the 25 milliliters volumetric flask. The C2, the one that you're finding from the graph, that's the concentration of the dilutions that you prepare from your aspirin tablet solution. So you're calculating C1, right? You have your C2, the 3 values that you're getting from the graph. V2 is the same for all 3, which is 10 milliliters. And then your V1 is the volume that you're taking from your solution of your aspirin tablet solution, your 0.1, 0.2, or 0.3 milliliters. So with that, you're calculating C1. So you have 3 values of C1. Now, you should look at your numbers. You should have similar numbers for those 3 values. That concentration, all 3 of them corresponds to the same solution. Remember, you're preparing these 3 standards from the same aspirin tablet solution. So you're going to calculate the average for these 3 values here, add them together, divide them by 3, and that's the average for the acetyl salicylic acid before the dilution, or your C1. Okay, so add the concentration here, the acetyl salicylic acid concentration for the standard 1 plus the one that you have for standard 2 plus the one that you have for standard 3, and that number divided by 3 will give you the average that you need right here. To find the most of aspirin in your stock solution, you need to do the number that you have in number 5, which is the average, times the total volume of your aspirin tablet solution, which was 0.025 liters. To find out the grams, again, if you have the moles, you can find grams by multiplying by the molar mass. The molar mass of acetylsalicylic acid is 180.16, so that molar mass times the number of moles that you calculated in number 6 is going to give you the grams of acetylsalicylic acid. Now the last thing that you have to calculate is the percentage of aspirin. Divide what you have in number 7, which is the mass of acetylsalicylic acid in your stock solution, by the mass of your aspirin tablet, which is what you have in number 3, times 100. That will give you the percentage of aspirin in the aspirin tablet, which was the objective for this experiment, to determine how much aspirin you have in an aspirin tablet.